Okay, first example is about a deterministic inventory model. We have different cost terms. Then we have two different scenarios for the demand in part 1 and 2, and we want to see different inventory costs for different scenarios that we have. And then we also need to calculate the effect on total yearly cost by falsely assuming that the demand is 200,000 instead of assuming that it is 242,000. Let's go to the Excel sheet that we have. So we have two demand scenarios, as you can see. 200,000, 242,000. Then we have ordering cost equal to 32. We have purchase cost, which is 8, and then we have interest rate. To do our calculations, we need to have inventory holding cost, and here the inventory holding cost is perceived as opportunity cost. So to calculate the inventory holding cost, I need to multiply the purchase cost and the interest rate, so it will give me the inventory holding cost. Then for the first part, I am going to calculate the optimal order quantity. EOQ formula, go to your slides and see how it looks like. I will just try to copy the formula that we had there in this cell. So it was square root of 2 times our demand multiplied by ordering cost divided by inventory holding cost. So it is 4,000. It is our optimal order quantity. We have a yearly demand of 200,000, and we will make orders of size 4,000. So we can say that in each year we are making 200,000 divided by 4,000, 50 orders. This is the number of orders that we make each year. In the next row, we will calculate inventory holding cost. The inventory holding cost is, if you remember from the slides, it is Q over 2 multiplied by H. It is average inventory level multiplied by inventory holding cost. So Q over 2 multiplied by H, which is my inventory holding cost. So it will give me 1,600. And then I have ordering costs. I will pay this ordering cost each time I make an order. I know that each year I'm making 50 orders, and for each order I will pay a cost of 32. So I will get the ordering cost equal to 1,600. So here we can see that at optimal order quantity, which is here 4,000, the holding cost and ordering cost are equal to each other. It is in fact what we saw in the figure. It is the crossing point of the two curves for the two different cost terms. And of course we have the total cost equal to the summation of these two costs. In the second part we will do the same calculations, but this time with the yearly demand of 242,000. So I have a square root of 2 times demand times ordering cost divided by H, which is my holding cost. Here the order quantity is bigger by 400 units, In a similar way, I can calculate the number of orders per year. So demand divided by Q, it is 55 orders per year. Inventory holding cost is the average inventory multiplied by the inventory holding cost or unit inventory holding cost. And then I have ordering cost equal to the number of orders multiplied by the order cost for each order. Again, of course, it should be equal. And I have the total cost equal to 3,520. Then I will move to the next part, in which I will try to calculate the costs if I make orders of size EOQ1, but when demand is larger, it's 2,000. It is 242,000. So let's start with holding cost. Here we have holding cost is the average inventory. The average inventory that we have is based in EOQ1, so it is over 2 multiplied by the inventory holding costs. So it will give me the holding cost equal to 1,600. If I make orders of size 4,000 and I have a demand of size 242,000, then in each year I will make for this, let's say, demand divided by EOQ. This will give me the number of orders that I'm making each year, right? So if I multiply it by the ordering cost, which is 32, then I will get the total ordering cost over 1 year. And of course the total cost will be the sum of these two costs. So this is the cost if I make a mistake in my calculations or the estimation of the demand, and this is the costs if I have the right demand values in my calculations. I can calculate the absolute difference between these two cost terms, so it is 16. If I make this mistake, so I will incur 16 units of 16 monetary units more cost, and I can also calculate the percentage of the impact, the impact in the percentage, so it will be the difference multiplied by, so it will give me 0.45%, which is a quite small number.